So in this class we are going to discuss about the various terminologies. So what are all the terminologies used in coordination compounds? Right, super. Okay, enna terminologies irukku paarenga. First, coordination entity. What is a coordination entity? Abdina enna abdinaka, it is a ion or molecule. It is a ion or molecule, right? Which consists of metal and electron donors. Metal and electron donors in square bracket. Consider an example. Consider FeCN6 4-. It is a coordination entity. It is in positive. It is an ion. Neutral molecule example, nickel tetracarbonate. So in this complex the charge of nickel is also 0. Okay va? So coordination entity na enna, adu oru neutral molecule ah irukkalam illa ion ah irukkalam. adula enna irukum, metalum and அந்த மெட்டலுக்கு எலக்ட்ரானை கொடுக்கறவங்களும் இருப்பாங்க. They are usually enclosed in square brackets. Okay, right. Then central metal atom or ion. What is the central metal atom or ion? Okay va? Right. So it is the one which occupies the central position, and donors around it. Enna donor? Electron donor and electron donors around it. Right. Example, paranga, say take the same complex. Here Fe, charge of Fe is 2+. அது எப்படி கண்டுபிடிக்கிறது நம்ம oxidation number ல பாப்போம். You will see here the charge of Fe is 2+. So it is the central metal ion. Since it is charged, it is called a central metal ion. Here the charge of nickel is 0. Nickel is in 0 oxidation state. So it is called as central metal atom. Okay, right. What is its main role in a complex? Means it accepts electrons from those donors. Donors கொடுக்கிற electrons வாங்குது. Electron வாங்குறவங்களுக்கு என்ன பேரு? They are called Lewis acids. That is the important point here. Clear? Right. So what is a ligand? Those electron donors which donate electrons to the central metal atom or ion, they are called as ligands. They are nothing but electron donors. Since they donate electron, they are also termed as Lewis bases. Very good. So what are Lewis acids? Means electron acceptors are Lewis acids, which are nothing but the central metal atom. And Lewis base na enna? It is nothing but the ligand which donates electron. Right. Then coordination sphere. What is a coordination sphere? Usually the central metal and the ligands, they are enclosed, n number of ligands it may be, they are enclosed in a square bracket. Which is called as the coordination sphere. Here consider, this is a coordination sphere, here it is a coordination sphere. Okay, so usually the metal along with the ligand which are enclosed in a square bracket is called coordination sphere. Right. Next, coordination polyhedron. Polyhedron means geometry. Right. So if consider here there are 6 ligands, all cyanide species, right? How the 6 will be located means, one cyanide, second one, third one, fourth one. These 4 cyanides will be in a single plane. See here, cyanide. Right. The 5th one will be from before the board, and the 6th one will be back side of the board. So this is a cyanide and this is a cyanide. So what is the shape of this compound? It is having octahedral geometry. Since there are 6 ligands, it is octahedral geometry. If it consists of 4 ligands, 4 ligands இருந்தா என்னவா இருக்கலாம்? அது tetrahedral இருக்கலாம் இல்ல square planar இருக்கலாம். It depends upon the strength or power of the ligand. Right, we will see it later. Then what is coordination number? Coordination number na enna அப்படினா, number of electron pairs accepted by metal atom or ion. So see here, in this complex Fe2 plus accepts 6 pairs of electrons from 6 cyanide species. Okay, so here the coordination number is 6. Here the coordination number is 6. Look here. Nickel accepts 4 pairs of electrons from carbonate, 4 carbonate species. So here the coordination number is 4. Right. We can say it in another different way. It can be defined as the number of donor atoms to which the metal is directly bonded. It may be termed as such also, right? Then, what is the oxidation number, sir? We are going to see more about ligands and oxidation numbers. We are going to discuss some more points about ligands and oxidation number. Simply, I will explain what is oxidation number in brief. Oxidation number means it is nothing but the charge left on metal. When we remove all the ligands, along with their electron pairs, after removing ligands with their electron pairs. Okay, what are the important terms? This is a simple idea. Coordination entity sir, ion charged species, molecular charge 0. Metal electron donors square bracket simple. Central metal atom central position it accepts electrons from the donors. So it is called as, since it accepts electrons, it is called as Lewis acid. Example, here it is the central metal ion, it is the central metal atom. Coordination sphere, similar to the entity. Coordination polyhedron is nothing but the geometry of the complex. It depends upon the number of ligand donors. Okay, since there are 6 donors, it is having octahedral geometry. Right. Coordination number, it is the number of electron pairs accepted by the metal atom. Here Fe2 plus accepts 6 pairs of electrons. Here nickel accepts 4 pairs of electrons. So the coordination number here is 6 and here is 4. Right. So we are going to discuss much more about ligands and oxidation number. Right. Now look here. Here we are going to discuss about the ligands. Right. Okay. So we are going to classify the ligands based on charge. Already I have mentioned ligands. They are electron donors. So since they are donors, they are called as Lewis bases. Right. So we are going to classify ligands based on charge. Charge classify right. So since charge based we are giving the names positive ligands, negative ligands and neutral ligands. What are positive ligands? They must have a positive charge and also they must behave as a donor. So here see, it is called as hydrazinium species, right? Here it is nitrosonium. Here it is hydronium. All these species, here it will donate the electron for a pair of oxygen. So they are all donors, but they are having positive charge. So they are classified as positive ligands. Right. Negative ligands. Then what are negative ligands? See here, they must have a negative charge and they must behave as donors. Donors are behave pannu. So they are called as, all these are examples of negative ligands. You must call, in this lesson you must name them as chlorido, fluorido, sulfato, oxalato. It is from oxalic acid, right? Okay. So then neutral ligand. What are neutral ligands? They are neutral, that is nothing but they don't have charge, but they may donate the electron pair. Example, carbonyl, nitrosyl, aqua. In this lesson it is termed as aqua. They are given special names. Amine. So here see, it is double M. In order to differentiate organic amine, organic chemistry amine morally are the single M. In order to differentiate, we are giving the name double M, right? Amine. Okay, this is one type of classification. Another type of classification, how we are going to classify ligands, means based upon the denticity. So what is meant by denticity, sir? It is nothing but number of electron pairs donated. Number of electron pairs donated. If one species, example chlorido, it will donate 1 pair of electron. So they are termed as unidentate or monodentate. So if a ligand is donating only one pair of electron, they are classified as unidentate or monodentate. If it is donating two pairs of electrons, it is called bidentate. Example, ethylene diamine. Ethylene diamine, it will donate the two pairs of electrons from the nitrogen atom. So it is also simply termed as En, right? Similarly, oxalate 2, it is oxalate 2. It will donate two pairs of electrons. So similarly, if a ligand donates three pairs, it is tridentate, tetradentate. Some other examples are there. Okay, we will go for directly. Simply, we can classify them all under the category of polydentate. In polydentate, I have given you an example, EDTA, which is nothing but a hexadentate ligand. It donates how many pairs? 6 pairs of electrons. So here, it is the structure of EDTA, from where you can mention. So here, 4 oxygens from the acetate species. 4 oxygens from the acetate species donates 4 electrons, and the 5th pair and 6th pair are donated by the lone pairs of nitrogen. Lone pairs of nitrogen. So one EDTA molecule is capable of donating 6 pairs of electrons. Hence it is termed as ethylene diamine tetraacetate, which is nothing but a hexadentate ligand. Right? Yeah. Right. Now we are going to discuss about the types of complexes. Right? See here. So we can classify complex in 2 ways. First classification is based on charge. So based on charge, we can classify the complex as cationic complex, anionic complex, and neutral complex. So cationic complex, complex cation is present. What is it called? See here the cation, it is the cation, which is a complex one. It is anion, simple ion, but it is a complex ion. So complex cation is present means it is called as cationic complex. See here anionic complex. This is the anionic complex. Why sir? It is consisting of a complex anion. It has a complex anion and simple cation. Right? What is a neutral complex sir? So the complex itself is having neutral charge. It is a neutral molecule, but it is a complex consisting of ligands and the metal. Then another type of classification is based on the ligands, nature of ligands, based upon the nature of ligands. See here, it is classified as homoleptic and heteroleptic complexes. What is a homoleptic complex? It is nothing but if the complex consists of same kind of ligands. If the complex consists of same kind of ligands. See here what are the ligands present? 6 ligands are present, and all the 6 ligands are ammonia molecules. So it consists of 6 ligands, which are nothing but all are ammonia molecules. So it is called as homoleptic complex. What is a heteroleptic complex? Here there must be different kinds of ligands present. Consider this example. In this complex, totally 6 ligands are present, right? 3 ligands are ammonia molecules, and another 3 ligands are NO2 minus ions. So it consists of 2 types. It consists of different kinds. That is 2 kinds of ligands. Hence it is called as heteroleptic complex, right?